All right, so this is your, not that, this is your 5-2 warm-up. I will tell you that I didn't put verifying on the quiz. It's like the other way around. It's where you have to simplify it, and some of them are short answer and some of them are multiple choice, so it kind of works like that. But it's just too hard to check your work in the time frame that I need to get these back to you before your test. So these will either be open-ended or they will be with multiple choice, which is kind of like this. But so for number 1, it says tangent squared over secant squared equals sine theta over tangent theta. Anybody want to walk me through how they did it?
And we're going to turn that into sine squared over cosine. And then the secant,
Yeah.
Yeah, the secant is going to turn to cosine, and then we're going to multiply that with cosine.
Okay, and
You're
then
going to cross those two out, and then you're going to just, yeah.
so I'm here, right?
Mm-hmm.
Then what?
And then you divide one, and then move the other one.
Good. So you can split that. So sine of theta can come off of the other one, and then it's sine theta over cosine theta. And then that's sine theta, tan theta. Good. Anybody do it differently? Going once, going twice.
So I did that one different.
Okay, how'd you do it, Francisco?
I ended up moving the secant to the top and made it cosine.
Okay.
And then I divided the tangent from the other side.
Okay, so you've got cosine theta tan squared theta equals sine theta tan theta. Divide both sides by tan.
Right.
Cosine theta tan theta equals sine.
Yeah, and then it would just be sine equals sine.
Time any 9th or 11th grade classes in the 100s and 300s, please report to the gym.
That works too. All right, number 2. Hopefully you took the easy route, which is just move them, right? If I move them, tangent becomes cotangent, cotangent becomes tangent, and order on addition doesn't matter. So you can take it to the next step, but you don't even need to, okay? Order does not matter on addition or multiplication. All right, then 3. So this is one people tend to miss, and that's your cofunction. Remember, if it's pi over 2 minus an angle, it's a cofunction. So the cofunction for cosecant is secant. And then you can replace secant with 1 over cosine. That becomes sine over cosine, and that becomes tangent. Yes.
Can you explain again, like when you're able to do that for number 2?
Only if it's a single term or part of a product. So like if it said 1 over tan x plus 1, I can't move the tan. If it said 1 over tan x cotan x, I can move them. I can move one of them. I can move both of them. Okay? If it's part of a product or, a sum or a difference, you can't move it.
11th grade classes in the 200s.
So if it said, let's say it said tan on top and then cotan on the bottom, I can move this up there. It just becomes tan times tan or tangent squared.
Okay.
Yeah, so you can move it as long, you can't break apart a sum. Other than that, you can move any part of a product, the whole thing or part of it. Okay, then, yeah. So you got to pay attention really closely to the instructions. It's both, okay? So this one says, and it should have a bracket and a parentheses. I don't know why I always forget that there's a typo on this one, but it should have that because you want to include 0, but you don't want to include 2 pi. You want to stop before 2 pi. That's what the bracket and the parentheses tells you. So remember that if I'm going to use my unit circle, which obviously I recommend, that tangent is still only on the right side if you don't have the interval. And then I would add the negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. And I would add on the tangents, 0, root 3 over 3, 1, root 3, negative root 3 over 3, negative 1, and negative root 3. Do at least that to make your life a little bit easier. Sai, you mean number 1 from the homework, right?
Yeah.
Okay. All right, so for number 1 here, okay, and it says it on the interval. So remember yesterday I said it gets a little bit trickier when you have it on the interval with the multiple angle. I'm going to show you what that means because that's happening in number 1. So normally I would split this up and I would solve it, and I would get the tan of 3x equals 0. So because the 3 is on the angle, this is one of those multiple angle ones, I find the tangent where it's 0 first, and then I worry about the 3x. So tangent is 0 at 0. So this would be 0 equals, and instead of it being x, it's 3x. And it would normally be 0 plus n pi for tangent. So it would look like that. And then I would have to divide all of it by 3. And I get x equals 0 plus pi n, or n pi over 3. So the reason this is tricky this time is because it's actually saying find them all on this interval, which means tangent has more than this answer. It's got 0, and then I have to add pi over 3. So it also has pi over 3 because that still falls in my range. And then I have to take pi over 3 and add pi over 3 to it again. And it's 2 pi over 3. And that still counts because it's between 0 and 2 pi. And then I have to take 2 pi over 3 and I have to add pi over 3 to it again. And I get 3 pi over 3, which is pi. And that's still between 0 and 2 pi. So I got to keep going. Pi plus pi over 3. This is 3 pi over 3. So that's 4 pi over 3, still in between 0 and 2 pi. 4 pi over 3 plus pi over 3. 5 pi over 3, still between 0 and 2 pi. If I add it one more time, I get 6 pi over 3, which is 2 pi, and I say stop before that, so I don't include that. So that part of my answer actually has to have all of these as the answer. 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. I want you to know that this happens, but I also want you to know it's not on your quiz. Like, I didn't restrict the interval with a multiple angle. I did restrict the interval, so what's going to happen with the other part of this equation you need to know how to do. But I didn't do it with a multiple angle, and that's when this craziness happens, okay? I just want you to know it's different. So the right side of it, I just set tan, I just do tan of x minus 1 equals 0, and tan of x equals 1, and tan is 1 from 0 to 2 pi, so my entire unit circle at pi over 4 and at 5 pi over 4. So the answer for this question is literally all of those. It's 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, pi over 4, and 5 pi over 4.
But for 5 pi over 4, isn't that outside of the what tan?
Right, but it's telling you in the directions to use your natural unit circle. So if it didn't say that, then my answer would be pi over 4 plus n pi. But because it says that, I use the whole circle.
And then why don't you multiply that by 3? Sorry, divide it by 3.
Because the 3 is only on this part. It's only on the left part. It's not on the other side. So then go ahead.
Why'd you add pi over 3 on all those first ones?
Because of this guy right here, right? So this says 3x equals that. And that means that it actually happens more often than normal. So when I solve, like normally, this is what's going to happen, I'll tell you on your quiz, is this part here. It's going to give you a multiple angle, which is that. You're going to solve it, and you have to adjust not only the answer, but also the interval. So I have to divide both those by 3, and then my answer for the quiz is going to just look like that, and I'll be done.
Oh, okay.
But because I won't restrict your interval on the multiple angle question. But If you do, not only do you have to take that 3, divide it by the interval, but then you have to, because it says, okay, now give me all of them from 0 to 2 pi. Don't just give me what they could be, actually give me them. So I have to add the pi over 3, then I have to add it again, then I have to add it again until I get bigger than 2 pi, or 2 pi or bigger than 2 pi.
Okay, so like for that second part of it, if the tan minus 1 equals 0 was its own question, and it had those same directions, that's how we would do it. And we'd ignore how like on the, you know how tan is on just the two
right.
quadrants?
Yep.
And on the unit circle, you switch them to the negatives, you ignore that one.
Correct. So if this was not there, then the answer for that would be pi over 4 plus n
Negative.
pi.
Okay.
Just that. And the quiz, think you're writing that in. So it's pi over 4 plus n pi like that. Or, because it's funny, I started to write it the other way and realized it's pin. So I did both. Okay, so you could choose it either n pi or pi n. I don't care how you write it, but every time you write pi n, it's pin. Like I was like, oh, that's a word. But yeah, either one of these would work if it didn't give you the interval. But because it gave you the interval, we restricted it to the entire unit circle.
Okay.
Just first one then?
Yeah,
So how come pi over 4 and the 5 pi over 4 doesn't have like the plus pi n?
because the restricted interval says just from 0 to 2 pi.
Okay.
So
So what
you
does
have.
the pi n do?
That's if there's no restriction. You're saying it's happening at that part of my circle, and then every part thereafter it, that's pi n away, or pi away. So the difference is the instructions. Do the instructions give you an interval? If it does, you look at your full circle and only answer those angles. If it doesn't give you an interval, then you have to add the pi n or the 2 pi n for the others.
Okay. And then the bracket means to include, and the parentheses means not to include.
Correct. And that will be the interval. It will be bracket 0 to 2 pi parentheses. So you'll include 0 as your answer, but you won't include 2 pi. Yeah, Sophia?
So you included the 5 pi over 4 because of the interval or because it was a multiple angle question?
Because of the interval.
Okay.
That one is not a multiple angle question. The multiple angle question comes in like from the 3x. Okay, that means multiple angle.
So when there's an interval restriction, you don't use just the 2 quadrants for tangent?
Correct. I hope that sunk in. I think that's the 4th time I said that, right? I hope everybody heard that. All right, number 2, secant squared x minus secant x equals 2.
I mean, you did give us that curveball. I was like, huh?
Which
You
one?
kept
The multiple
adding
angle?
You kept adding the pi over 3.
Yeah, that left side, but not the right side. That's the same. Yeah. Okay, so I'm going to move the 2 to the other side. Secant squared x minus secant x minus 2. I'm going to factor this. So it's secant and secant. Negative 2 and positive 1. Split and solve this. And I get secant of x equals 2. And secant of x equals negative 1. Flip it, because secant is not on my unit circle, but cosine is. The flip of negative 1 is still negative, the flip of negative 1 is still negative 1. So I'm looking for 2 things. One is where cosine is positive 1/2. My instructions say use the interval, so I'm using the whole unit circle. So cosine is positive 1/2 at pi over 3 and at 5 pi over 3. And my cosine is negative 1 at pi. So again, think in terms of words. This would be, and it's going to say put it in order of least to greatest. So it would be pi slash 3, comma, no spaces, 5 pi slash 3, comma, pi. Just like that. Again, no spaces. Okay, then the last one. So if it hadn't said on that interval, my answer would have been all those plus 2n pi. All right, I have two different trig functions. So what do you have to do first?
Make them the same.
Make them the same. Does it matter which one I make the same?
No.
It actually doesn't. Okay, before in the example we did yesterday, I had a cosine to the first and a sine squared. You can't replace a cosine to the first. But in these, it's a secant squared and a tangent squared, so I could replace either one. So think about what your trig identity says. It's tangent squared plus 1 equals secant squared. So I could literally not, without moving anything around, replace secant with tan squared x plus 1 plus tan squared x minus 3 equals 0. You could also, like I said, replace the tangent. It would be secant minus 1. Now I distribute this. I get 2 tan squared x plus 2 plus tan squared x minus 3 equals 0. Combine my like terms. 3 tan squared x minus 1 equals 0. Add the 1. 3 tan squared x equals 1. Divide by 3. Tan squared x equals 1/3. Square root both sides, putting a plus and minus in the front. And I get plus and minus the square root of 1 over 1. Square root of 1, which is 1 over square root 3, which gets rationalized to root 3 over 3. So it's not my normal one because I restricted my unit circle to 0 to 2 pi, which means use the whole thing. And it's a plus and minus 3 root 3, so it's happening at every single over 6. It's plus and minus, and root 3 over 3 is your over 6. So this would be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If I was to write that in pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 in order of size and no spaces. Questions on that one? Yes.
So on the quiz tomorrow, questions like this, are we gonna have the interval restricted or no?
Both.
No? So
No, I said both. Sorry, you're gonna have both. You're gonna have a question. I think it's 2 questions without the restriction and 1 with. So make sure you pay attention to your directions. So if it didn't give me the interval that time, then I would use just the right side because it's tangent. I would just get pi over 6 and negative pi over 6. And I would add n pi. So if this is typed in, it's negative pi slash 6 plus n pi or pin. I gave you either one. And then comma 7, no, sorry, can't even read my own handwriting. Pi over 6 plus n pi or pin, same thing. So without interval this, with interval this.
But then Ms. Crispizer, if you do it through the other one, not tangent, and you do it through secant, you get a different answer.
Yes, you do.
Are
So,
they both still right or no?
yes.
Okay.
So the question just came up, what happens if I had done this secant? So it would have been, if I had replaced tangent instead of secant, 2 secant squared x plus tangent gets replaced with secant minus 1 minus 3. 2 secant, come on my like term, so it's 3 secant squared x minus 4 equals 0. 3 secant squared x equals 4. Secant squared x equals 4/3. Square root both sides. Secant of x equals plus and minus the square root of 4, which is 2, over the square root of 3. Don't rationalize it yet because it's a reciprocal function. Flip it, so it's cosine of x equals plus and minus square root 3 over 2. So with the interval, my whole unit circle gets counted, and it's cosine, so it's every over 6. So the answer is the same. Without the interval, it doesn't get restricted. I use the whole circle, but then I add on 2n pi. So to every one of these, to pi over 6 plus 2n pi, to 5 pi over 6 plus 2n pi, to 7 pi over 6 plus 2n pi, and to 11 pi over 6 plus 2n pi. Technically, these are the same. They are the same answer, because for tangent, we're adding n pi, which means I'm going to take and keep adding half my circle, and on the bottom, we added in the extra angles, but we're adding every whole circle. So yes, both would have been marked correct on your quiz.
So that's just if the question, like if we would write it with the 2n pi, if it wasn't asking for the interval of
Correct.
0 to 2 pi. Right?
No interval, yeah. And then this is with interval. See how many of
Wait,
these.
so the,
All right, I'm going to try to get through as many of the homework questions as we can. It's good that we have extra time. All right, so number 5, this was yours, right? Yeah. So 3 cotangent squared minus 1, it would be 3 cotangent squared x equals 1, cotangent squared x equals 1/3, square root, 1 over root 3, flip it, plus and minus root 3 over 1. So this, did it give you the interval?
I said there was a lag, so when you it right now just went through super fast.
Sorry. Did it give you the interval? I got cut off. No, it didn't give you the interval.
I think I marked it wrong because I put the.
Yeah, but it should have been negative pi over 3. So it should have been negative pi over 3 plus n pi over 3 plus n pi. And it gave 2 pi over 3. So I would, the quiz is going to look for it this way. You did 4, yeah, which would have been, instead of doing negative pi over 3, you did 4 pi over 3. Oh no, you went third quadrant. You just did the wrong quadrant.
Yeah, where did the.
Should be right
2,
side.
3, 2, so then they used the whole.
They used the whole circle. Not even. They didn't even use fourth quadrant. They just didn't use the negatives and the positives. They used first into second.
Okay.
Yeah.
I was just really confused, like, with that, with those. Like, I kept my.
And that's it's hard because technically, well, but you didn't get the negative on there. That's what would have been wrong.
No,
4 pi over 3 is
I
not
realized
necessary.
the
Yeah.
square root mistake, but then, like, being annoying yesterday by the sign.
Sorry.
That's okay.
I mean, it's lots of times it's annoying. All right, 7, find all the solutions of your equation in the interval 0 to 2 pi. So now I've got tan squared equals 1, tan equals square root both sides plus or minus the square root of 1, which is 1. So this time it gave the interval. Make sure you include all of the angles on that interval. That's the only difference. So that was Noah's. I don't even know if he's here. Let me see. Yeah. Noah, did that answer your question? Just make sure, because it's restricted, you have to include the whole thing. It's weird that, like, if it's restricted, you think restriction would mean less, but it actually means more comma answers, but no plus whatever. So technically it is less answers, but it doesn't have as many options. This is 8. So this is Natalia. Okay, good. Find the solutions again on the interval. So this one said 24 sine squared x equals 24 minus 12 cosine x. So this is like an example where you can't replace either one. You can't replace cosine to the first with anything, so you have to replace sine squared. So remember, sine squared plus cosine squared equals 1, which means I can replace sine squared with 1 minus cosine squared. So 24 times 1 minus cosine squared equals 24 minus 12 cosine x. Distribute here, 24 minus 24 cosine squared x equals 24 minus 12 cosine x. Get everything to one side because you've got the cosine squareds and the cosines. I like to make my leading one positive, so I'm going to move everything that way. So I'd get it 0 equals positive 24 cosine squared x minus 12 cosine x, and then this is minus 24, so minus 24. Negative, or just cancels out, sorry. From here, I can take out a 12 cosine, and I get 2 cosine x minus 1. Split them. This side divide by 12, and it's just 0. The right side, 2 cosine x would equal 1, and cosine x would equal 1/2. And then, did it give you an interval? Yep, gave the interval, so we're using the whole unit circle. Cosine is 0 at 0, nope, at pi over 2, and 3 pi over 2. Cosine's 1/2 at pi over 3, and 5 pi over 3. And then I would put those in order from least to greatest. So it would be pi slash 3, comma, pi slash 2, comma, 3 pi slash 2, comma, 5 pi slash 3, if that was the answer on the quiz. You're just missing the 3 pi over 2 from this one.
Miss Chris Weiser,
Yeah,
from the beginning, can you divide all the terms by 12?
sure.
Okay, yeah, because that's what I did, because I didn't want to, like, subtract all, like, the bigger numbers.
Yeah. Avoid those big numbers as much as you can. Yeah, you can divide. As long as you divide everything by the same number, you can divide.
Different numbers, I had like 72 and 36.
Yeah, it always
But I
works
got
out the
wrong, I
same.
put the plus 2 and pi on it.
Just be careful. Yeah, I mean, it's good to catch it on the homework, right, before it counts.
Yeah. Yeah, for mine on that.
Okay, this was,
Further?
yeah,
So it's in general, if there's an interval restriction, you don't put either the 2 n pi or the n pi.
correct.
So for all true functions, okay.
Yep.
And then Mr. Says what
Yes.
it says to like, put algebraic, I don't know.
Solve it algebraically.
No, to put it algebraic.
That just means what we've been doing.
No, like the order, like, it would
Oh, put it in order of least to greatest.
Oh, it's like.
Yeah, it's going to say least to greatest, yeah. All right, number 9, this was Aaliyah. Okay, so tangent, this one you've got to replace, and I can't replace just secant, I have to replace tangent. So remember, tan squared plus 1 equals secant squared. So if I want to replace tan squared, it's with secant minus 1, secant squared minus 1. So this becomes secant squared, secant, I changed your color, sorry. Secant squared x minus 1 equals secant x minus 1. Move everything to the same. Oh, Aaliyah, you just can't include. You wouldn't include either of these. So your process is right. Here, I'll keep working it out just in case somebody else needs it. But add the one they cancel. Take out the secant. Set it equal to 0. So cosine would be undefined. Because you flip 0, it'd be undefined. And secant, or no, cosine. This would be equal to 1. So flip it, it's still 1. There's no such thing as cosine undefined on my unit circle, so I don't have to worry about that first one. But cosine is 1 at just 0. If I go 0 to 2 pi, not including 2 pi, and that's what the parentheses mean. So I only want 0 there. So I know WebAssign is like nitpicky about your format, so will Canvas when it grades your quiz, so keep that in mind. It would mark, like, and I would mark it wrong. I would leave it marked wrong if you included the 2 pi, because that's not part of your interval. There was more questions that came in on the chat. Let me see if I can get them all on here. All right, so the degree one said the tangent of x equals negative square root 3 on the interval of 0 to 360. So you're using your whole unit circle, but you're using the angles this time. I mean, I guess it's good that we've gotten so used to radians because they are the things that were foreign to us. But good old degrees can come back too. All right, so this says negative root 3. So when I get the interval, which is the whole circle, I want to go all the way around my circle and figure out where tangent's negative root 3. Tangent is root 3 at the over 3's, and it is negative here, and it is negative here. So the degree measurement there is 120, and the degree measurement here is 300. So it's 120 degrees and 300 degrees. And we don't add the interval because it restricted the interval here from 0 to 360. If it had, like, it's not going to happen in my class, but let's just say you saw something where it didn't restrict the interval, then you would do the 300 or actually it would be negative 60 plus, instead of adding n pi, you'd be adding 180, which is half of the circle, 180 pi. No, 180 n. But that, I mean, it won't happen for me. I just want you to know that that exists. And then 12 looked like this. So this is a multiple angle one that has a step before we get to that. I have to solve for the x over 9 by moving the square root of 3 to the other side. This did not restrict my interval, so this is a good example of what it would look like on your quiz because I didn't restrict it with the multiple angle. So tangent is negative root 3 at, oh, you know what, Sai? I would, no wait, you didn't, did you multiply by 9? Hang on, let me work it out. So I would have gotten x over 9 equals negative root 3 happens at negative pi over 3 plus n pi, and then I multiplied everything by 9. So it should have been x equals negative 9 pi over 3 is negative 3 pi plus 9n pi. So both the restriction and the angle has to get that 9. And again, typed in negative 3 pi plus, with no spaces, 9 n pi, or negative 3 pi plus 9 pi n. Either are those how you would type it in for the quiz tomorrow. Any other questions before I let you work on your own? All right, remember, quiz tomorrow on lockdown, no calculator. Obviously, if you want some scrap, no, you have to have scrap hard copy. If you want notes, they have to be hard copy too. Don't rely upon them so much that you don't get to finish. Okay, that's 30 minutes. You should have plenty of time to finish tomorrow's quiz, unless you get hung up, obviously. If you get to a verifying that you get stuck on, my advice is skip it and go back. Because remember, sometimes we have to restart and you don't want it to throw off your whole time. So for 5, yeah, I don't think it's that bad. I'll show you, and I don't think it's that bad, but no, there won't be. For 5.1 and 5.2, you really just need to know this screen, obviously, and then how to apply it. There's actually a quiz, because yes, I know you're going to have this, but you want it to be fast. You don't want to be looking for things or forget about something. So there's also a quiz that goes through all of these on the module. I don't know if it's published yet. I will publish it, okay? But pay attention to things like squares, obviously, make me think Pythagorean identities. Negatives on the angle make me think even odd. And then pi over 2 minus something should make you think cofunction. So just keep that in mind. I'm going to try to do my best to make sure I go, but especially the ones that are open-ended that have possible answers. Those are going to take me some time to grade, so just be patient with me. But make sure that you show all of your work so that I can give you credit for those things. If you come with some off-the-wall way to do something, but it works, I want to give you credit for it, and I can't do that if you don't show me work. And then there's a bunch of practice problems for this, obviously, on your quiz review, and the warm-up for 5.1 and the warm-up for 5.2. There's lots. And then some of you did the 5.1 homework on WebAssign. It's there if you didn't do it, because those also have extra practice problems. And then 5.3, so just keep in mind that we're solving, right? So we're going to solve the equation however we do. Sometimes it's just solving straight up. Sometimes there's a multiple angle. Sometimes you have to do replacement. Sometimes you have to factor. So there's going to be different ways to solve, to set up in the beginning. But then remember that if it doesn't give you the intervals, so I've said it a couple times, but I want to really reiterate this. If it doesn't give you the interval, that to your sine and cosine, you use your whole circle, and then you add plus 2n pi or 2 pi n, because it doesn't matter. So on my typed versions, it's going to be 2n pi like that, or 2 pin like pin, okay? And then to tangent, we only use the right side, negative pi over 2 to positive pi over 2, and we add n pi, or again, pin. You can use either one. No spaces on those answers. Those are all open-ended. The only ones that, there's 3 multiple choice mixed in with the verifying, but all the solving are open-ended. And then if it does give you the interval, the 0 to 2 pi, then we use the whole natural unit circle. Whether it's sine, cosine, or tangent, you use the whole natural unit circle. Okay, the only other thing is pay special attention to your multiple angle ones. So obviously, if it says something like the sine of, 8x equals 1, that I need to solve for where sine is 1 first, which is going to be at pi over 2, plus 2n pi, and then I have to divide everything by 8. And I get x equals pi over 16 plus n pi over 4. Both your answer and your interval get affected. And then for now, we're just going to stop there. Remember, I said that that's like the example 1. If it's on a restricted interval, it's yucky, but I didn't restrict your interval with a multiple angle. And then if this was like sine of x over 8 equals 1, I'd still start with the same answer, so pi over 2 plus 2n pi, but I'd get 8 over x equals that, so then I'd multiply everything by 8. And I'd get x equals 8 pi over 2 plus 16n pi, and as always, we would reduce, so it's 4 pi plus 16n pi as an answer that is typed in, which is what this would be. It would either be like that, or n pi, or like that. This would be pi slash 16 plus n pi over 4, or pi slash 16 plus pin over 4. Again, those will be typed in answers, so keep that in mind.
Chris Weather?
Yeah.
For the multiple angles, what do I do if it's like more than one, like if it was cosine 0 equals 0?
If it was more than 1. Like, if it, I got you. Okay, so cosine of x equals 1. You're saying like that. So if it was 8x like that, so there's 2 answers, that's still just one answer. You mean like, what if it said sine 8x equals, let's say root 2 over 2. So sine of x is root 2 over 2, 2 places on my unit circle, right? It's at pi over 4 plus 2n pi, and it's at 3 pi over 4 plus 2n pi. So then 8x equals both of those. So I would divide everything by 8 twice. So I get x equals, it'd be pi over 32 plus n pi over 4, and then 3 pi over 32 plus n pi over 4. So both of these would be your answers. Typed in, that would be pi slash 32 plus pin over 4, comma, 3 pi over 32 plus pin over 4. Did that answer your question, Sai?
Yes.
Okay, perfect. Okay, so if you are good on homework, you can start your quiz review. Okay, you can take a little brain break. You just can't nap, Victor. Be productive. Okay, if you have the homework questions, I'm going to keep going. But feel free to, if you're good on questions I have left to go over 1 and 12, and 9. If you're good on those, feel free to work on your quiz review.